Let me start by sharing my screen. First of all, good morning, good afternoon, good evening. Bonjour, buenos dias, buongiorno, guten tag. We welcome all of our good friends from around the world. Special welcome to our friends at Tufts University, at Brigham Young University, University of Toronto, Technium Wien, and all the other faculty and students and friends that have joined us today. We're so excited. This is our first summit. I think it's the first of many summits that we will have. And it is especially focused on digital transformation. So I hope you'll forgive me if I start with a personal anecdote. If I go back in history, back to the beginning of my career, I began my career in 1980 as an intern at the Naval Weapons Center, working on a brand new technology called computer-aided design. And as most of you know, we tend to think that Ivan Sutherland's dissertation at MIT called Sketchpad as indicating the beginning of this new technology, computer-aided design. There were a lot of different activities going on by a lot of different people and companies at that time, but we tend to look at Ivan Sutherland as the father of CAD. And by 1970, there were all kinds of what we call turnkey CAD systems. They're called turnkey CAD systems because when you bought one, you got a key, and hardware and software was shipped, and you'd put the key in and turn the CAD system on. Names like Computer Vision, Applicon, Autotrol, all kinds of systems at that time. And shortly thereafter, there was a paper published that talked about a new concept where we had been able to turn drafting and design digital. Now, all of a sudden, there was this idea of, well, maybe we could turn everything within a factory digital. And so the paperless factory concept came out in 1970. I remember as I started my career, all kinds of discussions about paperless factory and how within 2 or 3 years, all factories would be paperless. And really this paperless factory concept was just part of the progression of the industrial revolutions. I'm sure all of you are familiar with the concept of the first industrial revolution, where we saw mechanization, specialization of labor. And then following that, a focus on mass customization. And the CAD and paperless factory really came in between Industry 2.0 and Industry 3.0. And today we're really right in the middle of Industry 3.0, automated production and this new flow of information. And we're talking about another industrial revolution called Industry 4.0, smart connected products, smart connected processes, factory, etc. And as we look at that, we're also experiencing the effects of the COVID pandemic. And the COVID pandemic really kind of emphasized the need to move more quickly towards this Industry 4.0. Our CEO, Jim Hempelman, likes to say that you can't put the genie back in the bottle, meaning that during this pandemic, we used digital technologies that we had been hesitant to really fully implement before, but we had to in order to function during the lockdown. And that was true both for industry and for education. And what we discovered was we could be actually even more productive if we fully implemented these digital technologies. And there are really kind of 6 aspects to these digital technologies. When you implement this full digital capability, you free up desk workers so that they can work anywhere, anytime. The supply chain becomes more frictionless. Products and factories now suddenly become connected. I think one of the most exciting aspects of this technology was bringing digital to the front line so that frontline workers actually were more connected now. artificial intelligence and virtualization through spatial computing. All these things we began to experience, and now we're at a point where we're saying, okay, we're coming out of the pandemic. Some parts of the world are coming out of the pandemic, and we're thinking, all right, now what do? We can't put the genie back in the bottle. How do we really fully embrace Industry 4.0? And one of the things that I experienced in my career was something called the law of inverse consequences. And I'll talk about it in reference to the concept of paperless factories. What we discovered was that in 2 to 3 years, we didn't go to paperless factories. In fact, the technology that we implemented, this CAD, had digital plotters and printers, and all of a sudden we realized we could generate paper faster than we'd ever been able to before. And what happened was exactly the opposite. We generated way more paper than we ever generated before. And the implementation of technology into our old processes tends to cause this law of inverse consequences. We like to take new technology, but we're kind of holding on to our old processes. And so we stick the new technology in our old processes and we get just the opposite effect. So the real question today is, how do you implement digital transformation without incurring the law of inverse consequences? And that's a really important question. And there are companies who will say, yeah, hire us and we'll show you how to do this. But in general, nobody has the complete answer to how you do this. In fact, that's the whole reason for this summit, is for us to come together because we're all working on this same question. How do you implement this? But now that's been talking about industry. Let's stop for a second and step into ACADEME. Here I show 3 maps for mechanical engineering curriculum from universities here in the US. And the thing that's the most remarkable to me is the fact that I went to school like half a century ago, and my map doesn't look significantly different from the maps today. I think it's interesting to note that between Industry 2.0 and 3.0, we had the space race, and that really significantly changed engineering curriculum. We implemented more math, more physics, more chemistry as we moved from an empirical design process to a predictive design process. But ACADEME has not necessarily embraced the movements of Industry 3.0 and now Industry 4.0. I do notice that we have mechatronics integrated in. Some curricula has CAD. Some has a little bit of CAE in there, but in general, things have not changed a lot. And the real question comes up of, how do students prepare themselves to be ready for stepping into industry? Once they graduate and move into the industrial sector, they're expected to know technologies and languages like CAD, CAM, CAE, PLM, PDM. And the fact is, we don't cover that in ACADEME. We don't really prepare them. Some of the programs will expose students to CAD, a little bit to CAE, but in general, they won't see CAM and they won't see PLM and PDM. And the fact of the matter is, that's only the beginning. There's a whole lot more technologies and languages like computer-aided production planning, or production planning and control, computer-aided quality control, computer-aided inventory management and control. There's so many other threads. And really, when we talk about Industry 4.0, what we're saying is, not only do we want to go to a paperless factory where all the information associated with the digital thread throughout the process of product development, we want to be able to store that information. That's what creates the paperless factory. We want to store it digitally. But for Industry 4.0, we want to go one step further, and that is to use that information to control the operations throughout the digital thread so that we can optimize those operations and achieve the things that we want to achieve in the factory itself. And how do you do that? Well, it turns out that connectivity is the key. And what I mean by connectivity is our students need to know these different technologies of CAD, CAM, CAE, PLM, PDM, etc. They need to know those technologies, but they need to know how to connect those technologies, because it's the connection of those technologies that really gives us the ability to implement Industry 4.0. And that connectivity is the whole focus of our digital transformation summit today, and our digital transformation work that we've been doing with you is really focusing on how do we figure out how to connect these technologies, but not only how do we figure out how to connect them, how do we figure out how to teach students? How do we figure out how to integrate this into our curriculum so that students are prepared as they step into the workforce, not only to work effectively as the next generation workforce, but they're able to actually pull this Industry 4.0 into the commercial sector and bring about the transformation that we're looking for. But that isn't the whole story, because while this is going on, this industrial revolution of Industry 4.0, there are new technologies that are coming online, and students have to be familiar with these new technologies. For example, and this is another great example of taking our technologies and trying to stuff them into our old processes. We have this unbelievable internet and now cloud computing capabilities. And what we're seeing is that a lot of companies are taking their software that was designed for on-prem and just kind of hosting it in the cloud. And so you get this CAD in the cloud, or CAE in the cloud, or other kinds of technologies in the cloud. But in reality, it hasn't changed the whole approach or strategy. One of the reasons that we acquired Onshape a year and a half ago was because they represented a brand new way of utilizing cloud technologies. Onshape really took the approach of redesigning their technology to fully embrace the capabilities of cloud computing. And because of that, they can offer simultaneous collaboration. They can do optimization of their system that gives them scale that no one else can do. It's really an unbelievable capability that comes with Onshape. These are the kinds of things that we want our students also to be familiar with, because once you get this cloud computing capability, if you can connect into it, now all of a sudden all kinds of capabilities are available to us. So these are the kinds of things that we're going to be focusing on during the summit. And of course, once you are able to connect everything together, all of a sudden things like digital twins are a possibility. And digital twins, once connected to IoT and AR, allow us to see things we've never been able to see before, and really do things we've never been able to do before. So that's really the hope of this summit, is for all of us to come together, figure out how do we connect these technologies, how do we really bring about digital transformation Industry 4.0, and how do we teach our students and prepare them to fully embrace this new world. So thank you so much for joining. We're really excited for the presentations of today. I'm looking forward to not only the presentations from our faculty members, but also from the students in the student poster session, and then our wrap-up presentation that will be given by Dave Corcoran from Onshape. So really excited for the summit. Welcome again, and we'll talk soon. Thank you.